Good day, everyone. I am Charlotte Ramos, together with my co-researcher Jaren Duduran and our advisor, Sir Mike Camisilio. We're here today to present our research study entitled A Path Analysis of Student Problem-Solving Efficacy, Critical Thinking, and Beliefs on Mathematical Collaborative Problem-Solving Skills. In the 21st century, the ability to collaborate and solve complex problems is an essential skill, especially in mathematics, where real-world challenges often require a teamwork or group effort, and critical thinking. However, many students still struggle with working effectively in teams, thinking analytically, and believing in their own capabilities to solve problems. This study seeks to explore the relationship between three key factors: problem solving efficacy, critical thinking, and mathematical beliefs, and how they influence student mathematical collaborative problem solving skills. Drawing this is from the theories such as Bandora's social cognitive theory, cognitive load theory, and constructivist learning theory. This research investigates how these cognitive and physiological variables work together to shape students' collaborative performance. This study was conducted among grade 10 students in Compostela Davao de Oro. The study aims to provide valuable insights and that can guide the development of more effective teaching strategies, foster 21st century skills, and enhance student mathematical learning experience. And these are the possible research questions. What is the level of student problem-solving efficacy in terms of social persuasion, physiological responses, vicarious experience, and mastery experience? Second is, what is the level of student critical thinking in terms of interpretation, analysis, evaluation, inference, explanation, and self-regulation? And third is, what is the level of student beliefs in terms of difficult problems, steps, understanding, and word problems? Fourth is, what is the level of student mathematical collaborative problem-solving skills in terms of social skills and problem-solving skills? Fifth, is there a significant relationship between student problem-solving efficacy, critical thinking, beliefs, and collaborative problem-solving skills in mathematics? Lastly, is there a significant relationship between problem-solving efficacy, critical thinking, and beliefs?
And now let's talk about the research methodology. This research methodology outlines the plan for our study investigating relationship between different variables related to mathematics education. First is the research design. This research uses a quantitative correlation design to explore how different factors such as students' belief in mathematics, problem-solving efficacy, critical thinking, and mathematical collaborative problem-solving skills are related without manipulating any variables. And path analysis will be used as a specific statistical technique. Path analysis is a type of multivariate analysis that examines the direct and indirect relationship between a set of observed variables. And the next one is the setting and participants. Second is the research local, which is a selected national high school within our municipality of Compostela, Davao de Oro. This specifies the geographical location where our data will be collected. Third is the research respondents are the grade 10 students from the different national high school for the school year 2024 to 2025, which are the Compostela National High School, Maparat National High School, and San Miguel National High School. The fourth is the research instrument or the data collection instrument. This study will utilize the following instruments to gather data from the grade 10 students. First is the problem-solving efficacy by Dagdag et al. 2020. This instrument will likely measure the students' belief in their ability to successfully solve mathematical problems. Second is the critical thinking by Payan Carriera et al. 2016. This instrument will assess the student's skill in analyzing information and making reasoned judgments in a mathematical context. Third is the belief in mathematics by Klosterman and Stage 1992. This instrument, which we discussed earlier, will be used to understand the students' attitudes and belief about the nature of mathematics and their engagement with it. And lastly, the Mathematical Collaborative Problem-Solving Skills by Medina et al. 2019. This instrument will assess the students' abilities to work together effectively to solve mathematical problems. And lastly, the data analysis. This data will be collected using validated instrument or our validated instrument and analyzed through statistical techniques like means, medians, correlations, and path analysis to identify both direct and indirect relationship among these variables. The next one is the letters and forms. Before gathering data, it's very important to have official letters and approvals because they give permission and show that this research is legal and ethical. These documents make sure that the safety and the rights of the participants, like students, are protected and that the research tools have been properly tested. Without this research could be considered disrespectful, unreliable, or even wrong. First is the REC approval. The REC approval confirms that the research follows ethical standards and protects the participants' rights and safety. Second is the Dean or the ASD endorsement, shows the academic and local education office support this research. Third is the SDS approval, is the final permission from the school division head allowing the study to be done in the selected school. The next one is the letters and forms. Before gathering data, it's very important to have official letters and approvals because they give permission and show that this research is legal and ethical. These documents make sure that the safety and the rights of the participants, like students, are protected and that the research tools have been properly tested. Without this research could be considered disrespectful, unreliable, or even wrong. First is the REC approval. The REC approval confirms that the research follows ethical standards and protect the participants' rights and safety. Second is the Dean or the ASD endorsement, shows the academic and local education office support this research. Third is the SDS approval, is the final permission from the school division head allowing the study to be done in the selected school. The fifth one is the pilot testing. The pilot testing results show how the researchers tested their questionnaires ahead of a time to check for any issues and ensure that the tools work well. This includes some data analysis and possible diagram to show these findings. And lastly, the Form 6A, it helps the documents and approve the research plan officially within the school or institution. And now let's talk about the results and discussion of our SOPs or the statement of the problem in this study. Is what is the level of students' problem-solving efficacy in terms of these indicators? This table shows that the students demonstrated a high level of confidence in their problem-solving abilities across all indicators, including mastery experiences and social persuasion. Their psychological and emotional response to problems were generally positive and supportive of effective problem solving. Overall, the result shows strong problem solving efficacy, mean equals 3.92. Second is OP is what is the level of students' critical thinking skills in terms of these indicators. This table presents that the students showed a high level of critical thinking across all dimensions such as interpretation, analysis, and inference. They were particularly strong in identifying logical relationships, drawing conclusions, and self-regulating their reasoning processes. The overall mean score of 4.01 reflects well-developed critical thinking abilities. The third is OP is what is the level of students' belief in terms of these indicators. This table shows that the students displayed low to very low levels of positive belief in mathematics, especially regarding understanding and solving word problems. They generally disagreed with statements that reflect confidence or comfort with difficult or conceptual math tasks. This low overall belief score mean equals 2.30 suggests a need for further attention in this area. And the fourth is OP is what is the level of students' mathematical collaborative problem solving skills in terms of these indicators. This table presents that the students show the high skills in collaborating with peers and solving problems within group settings. Both social and individual problem solving abilities were rated positively. The overall mean 3.59 indicates strong collaborative problem solving skills.
This result is for the question: is there a significant relationship between student problem solving efficacy, critical thinking, beliefs, and their collaborative problem solving skills in mathematics? This table analyzes in how student problem solving efficacy, critical thinking, and beliefs relate to their mathematical collaborative problem solving skills. It uses correlation values and p-values to determine their significance. First is the problem solving efficacy, or all aspects: overall social persuasion, physiological response, vicarious experience, mastery experience, show statistically significant positive relationship with collaborative problem solving skills. While the self-regulation had the strongest positive regulation, meaning students who manage their own learning will tend to collaborate better in math. Second, the critical thinking are all areas: overall interpretation, analysis, evaluation, inference, explanation show significant positive correlation with collaborative skills. This means students who think critically are better at working together to solve math. Third is the beliefs, or none of the beliefs related variables, such as the beliefs complex problems, steps, understanding word problems, show significant relationships with collaborative problem solving skills. This suggests that the student beliefs about problem solving don't strongly influence how well they work together on math problems. Overall, the student with higher confidence in their problem solving abilities and stronger critical thinking skills tend to perform better in collaborative math tasks. However, beliefs about problem solving doesn't seem to directly affect collaborative success, which could be an area for further research. The correlation will, while significant, are moderate, indicating that other factors might also influence collaborative problem solving skills. The Pearson correlation coefficient revealed weak positive and statistically significant relationship between all the mentioned problem-solving efficacy and student mathematical collaborative problem-solving skills. Overall, problem-solving efficacy R equals 0.239 and the p-value is less than 0.001. Social persuasion have as what you notice in the table, the Pearson correlation coefficient revealed a weak positive and statistically significant relationship between all dimensions of problem-solving efficacy and student mathematical collaborative problem-solving skills. In the sixth question, is there a significant relationship between problem-solving efficacy, critical thinking, and beliefs? This table presents the correlation coefficient and the p-value for each relationship. The R value indicates the strength and direction of the linear relationship between two variables. It ranges from negative 1.00 to 1.00. A positive R value means positive correlation, as one variable increases, the other tends to increase. A negative R value means a negative correlation, as one variable increases, the other tends to decrease. Large P value, typically greater than 0.05, indicates that the observed relationship is not statistically significant, and we fail to reject the null hypothesis. The findings suggest that several factors related to self-efficacy or the problem-solving efficacy, like social persuasion, physiological response, vicarious experience, and mastery experience, have statistically significant and generally strong positive relationships with critical thinking. This implies that individuals who feel more capable in problem solving are influenced by social persuasion, experience positive physiological responses in challenging situations, learn from other experiences, and have had a successful mastery experience tend to exhibit a higher levels of critical thinking. Various specific beliefs about complex problems, steps, understanding, and word problems did not show statistically significant linear relationship with critical thinking. In this table present the first structural relationship was PSE into CT, which is estimate the 0.640 p-value less than 0.001. This path is strong and statistically significant, indicating the higher levels of PSE significantly increase CT. This supports the hypothesized model that suggests that PSE is a strong predictor of CT. Second is the B as a predictor of CT, estimate negative 0.054 and p-value equals 0.49. The path from B to C is not significant. This indicates that B does not have a meaningful direct effect on Third CT. Is the mathematical collaborative problem solving skills, and the CT estimates 0.051. The p-value is 0.499. There is no significant relationship between the critical thinking and the mathematical collaborative problem solving skills. This suggests that the influence of critical thinking on mathematical collaborative problem solving skills may not be a direct or stronger enough to detect. Fourth is the mathematical collaborative problem solving skills and the problem solving efficacy, estimate 0.113 and the p-value 0.066. This path is marginally significant, meaning there is a potential positive effect of PSE on mathematical collaborative problem solving skill. This warrants further explanation, possibly with a larger sample size. And lastly, the mathematical collaborative problem solving skills to beliefs estimate negative 0.165 or the p-value is 0.061. This relationship is also marginally significant, suggesting a possible negative effect of beliefs on mathematical collaborative problem solving skills. This result is not conclusive but may be relevant in future studies. This table presents the structural relationship. The only remaining hypothesized relationship in this parsimonious model is the problem-solving efficacy to critical thinking. This suggests that after removing the non-significant parts involving the beliefs and mathematical collaborative problem-solving skills, the model now focuses solely on the influence of the problem-solving efficacy on critical thinking. The estimated coefficient for this path is the 0.639. This is very similar to the estimate 0.640 we saw in the initial model of the standard error. The standard error is 0.034, which is also the same as the previous model of the CR in the critical ratio. The critical ratio remains 18.850 and the p-value is the ST. This table presents the result after we've likely trimmed the non-significant pathways from our initial, more complex model. What we see here is that the strong positive and statistically significant relationship between the problem-solving efficacy and the critical thinking remains at the focal point. The estimated coefficient of 0.639 tell us that for every 1 unit increase in PSE, we expect to see the substantial 0.639 unit increase in critical thinking. This effect is highly unlikely to be due to the chance given the very small p-value p greater than 0.001. The fact that this is significant relationship persists even after removing the non-significant path strengthens our confidence in the influence of the problem-solving efficacy on critical thinking. The table presents the chi-squared statistic test, the null hypothesis, that there is no significant difference between the covariance matrix implied by our model and observed covariance matrix. A non-significant chi-square or the p less than 0.5 is generally desired, indicating a good fit. Here, the chi-square value is 17.766, the degrees of freedom present at the number of independent pieces of information available to estimate the model parameters.